Okay, so one of the things I've noticed is that some of you are not doing very well with dimensional analysis in Quest. So I wanted to give a little lesson to those who are having some issues with dimensional analysis, just to remind them again how it works. Some of you may not have taken general chemistry last year, and so the only time you might have seen this is in biology, which might have been 2 years ago. So let me kind of go over 3 example problems and how to attack these problems in class. So one of the first things I want to talk about is whenever you solve a problem, you want to go through a particular procedure when solving the problem. And given, find, process, and solve is the procedure I want to give you. And what does this mean? So problem solving, of course, is an important skill in chemistry. And if you don't have good procedures, it can make it difficult for you to attack a problem. So the first thing you always do in solving a problem is look at the given. So G means given. Given means after identifying the problem, you need to organize all the information that is given to you. There are a lot of instances in chemistry where a given is not listed, but you should know. So in particular, these conversion problems that I gave you on the Quest assignment, there are instances where I don't even give you the conversion. You can always look them up. Feel free to Google the conversion between kilometer and meter if you don't know it, between gram and kilogram if you don't know it. But over time, you better figure these out. And just like I mentioned in an earlier lesson, there are certain prefixes you should know. And if you don't know them, it will make it difficult for you to succeed on the AP exam. Find, F. Find means you have to ask the question, what are you trying to find? What are you looking for? And by identifying what you're trying to look for, it'll give you a direction as to how to attack the problem. Process. Now there's lots of processes in chemistry. It could be a conversion problem, just like the ones in the Quest assignment. It could be stoichiometry, which is another different type of conversion problem. Or you can use an equation. Most of the time in physics, you're using an equation, but in chemistry, you're either doing conversions or equation or both. And so you need to be ready to use all those skills when solving a problem. Your understanding of concepts and those models that we talked about can really guide the process. And we'll talk about that as we solve more problems in class. Last but not least, try the process. If it doesn't work, try a different process. And the idea is you don't get better at problem solving by not trying to solve a problem or by listening to me solve problems or looking at how I solve problems. You get better by trying and trying and trying and trying. So don't ever give up. Keep trying. But of course, at some point in time, if it's taking too long, come and see me and we can, of course, walk you through it. But just don't get frustrated if I don't give you the answer immediately and I start asking a bunch of questions about what's given, what are you trying to find, what process are you planning on using. Okay, and then show me the work that you've tried something, because that's typically what I'll be asking before I even give you any kind of answers. So let's talk about dimensional analysis. Dimensional analysis is just a way of changing units from one type of unit to another, whether it's from feet to meters, miles to feet. There's different ways to convert it. And the way we use is basically what we call a T-chart, or using parentheses with fractions. And so we use conversion factors to change the units. And what is conversion factors? Conversion factors are anything that is equal to 1 when you basically write them as a ratio. So we know that 1 foot equals 12 inches. Those two are always equal. That's an exact statement. Those have infinite sig figs. And when you write them out, you can write them out either as 12 inches over a foot as a conversion, or you can write it as 1 foot over 12 inches. Both of these, since they're equal, are equal to 1. And that's what makes it a conversion factor. And the idea is by multiplying by this, you never change the number. All you're doing is changing the units. Okay? Not how big the number is, just the units. And so these are 2 different ways of writing those same ratios. Okay? Multiply by 1, that will give you the correct units in your answer. So the idea is that you just have to pick one that's going to best work for you. If you're starting with feet, you're going to use the one with feet on the bottom so you can cancel it out. If you're starting with inches, you're going to use the one with inches on the bottom so you can cancel that out. So let's show you an example of this. Actually, one other thing I want to talk about. There's proper use of unit factors leads to proper units in your answers. And so it's okay to use kilometer over 0.62137 miles, or 0.62137 miles equal 1 kilometer. However, it's not okay to use 1 kilometer as 0.62137 miles and 1 mile is 0.62137 kilometers, because these two are not equal to each other. 1 kilometer is shorter than a mile. That's why it takes less than a mile to make 1 kilometer. And so don't ever mix the numbers up when doing your conversions. That's one of the errors I typically see in general chemistry. It's something needs to be eliminated in this class. Okay? So example number 1. The Kentucky Derby race is 1.25 miles. How long is the race in yards? And of course I could quickly Google how many yards are there in a mile. But of course, for this particular problem, before I do that, I want to actually write down what is given, and I put that on the left-hand side. What am I looking for? What am I trying to find? Actually, so here are some conversions for you to help out, and of course, what am I trying to find, which is yards. So hopefully in the conversions you'd be given something like this. If you're not given these, of course, then you might have to look them up. And so based on this, which one should I use first? Well, in my process and solve, I would use, of course, my conversion factors. I'd use these as ratios. And since miles is what's given, I'm going to put miles on the bottom for my first step, which means the 8 furlongs belong on the top. In my next step, now, of course, that my miles are canceled out, I need to cancel out my furlongs. Well, to cancel out the furlongs, and now that I've used this, to cancel out the furlongs, I need to use this one. I'll put the 1 furlong on the bottom, the 40 rods on the top, and I wind up getting that. This cancels out my furlongs. Now I'm in rods. And last but not least, because I'm now in rods, I need to cancel out the rods. So I'm going to put the 2 rods on the bottom, 11 yards on top, and I get this. And so my rods now cancel, and my units will be in yards, which is what I want. And when I plug this all in the calculator, I get 2,200 yards. I could have easily done this by just looking at the conversion between yards and miles. But I wanted to show you something that has multiple steps in your practice so you get an idea how to cancel all of them. Okay, so you get an idea how to cancel. So this is basically 1.25 miles is equal to 2,200 yards. Now you'll notice this one has 3 sig figs, and this only has 2. How do I communicate this as 3 sig figs? You're going to have to write in scientific notation. 2.20 times 10 to the 3rd yards. And that would be the example number 1. Okay, so let's clear that out. Go to the next example. So in example number 2, here it says a park in Irvine is 1 square mile. How many square yards is it? Sorry, that's a typo. Is it? And so a couple of things you need to know. That's my given, and 1 mile is 5,280 feet. 1 yard is 3 feet, and I'm trying to find square yards. And again, this type of problem showed up on the quest assignment. So then how are you going to deal with this? These are square miles and square yards. Well, since I want square miles, I need to square my mile. And if I want that, that means I have to square both sides of the equation, just like algebra's taught you. Whatever you do to one side, you got to do the same on the other side. And likewise, because I'll have square feet, I'll have to square my yards as well. So a couple things you need to know is that when you square this, you're going to have to square both the number and the units. Both the number and the units, both the number and the units. So for the easy one, 1 yard squared, because 1 squared is 1, it's now going to equal to 9 feet squared. Okay, so if you have a square yard, there's really 9 square feet in there. What does that mean? Here, let's say this is my square yard. Since there's 3 feet in a yard, that means I'll have 3 square feet inside that yard. And so picture-wise, that's what that looks like. And of course, hopefully by now you've learned all this before. That's where there's going to be 9 in there, because there's 3 feet in 1 yard. So hopefully that picture helps you. And this is just an area analysis. And so when I plug this in, I'm going to need mile square on the bottom first. Feet goes on top. And so I plug that in and I square that. And I plug in, of course, the next one, which I want to cancel out my feet. So I'm going to plug in my feet on the bottom, yards on top, and I'm going to square that as well. That's another way of doing it on your calculator. So when you plug this in, you're going to 1 times 5,280 squared divided by 3 squared. And on the calculator, you get 3,097,600 yards squared. And when you analyze that some more, since I only have 3 sig figs, I need to make this 3 sig figs. It becomes 3.10 times 10 to the 6 yards squared. So that's how that works. And then last but not least, science fiction talks about warp factor. What is speed in miles per hour? A couple of things I would have to give you. Warp is that, speed of light's that. So why don't you try this problem? I'll pause. Why don't you pause it here, try it out, and then see how that works. So when you do this, of course, you now need to multiply 5 times the speed of light. Since the speed of light is in meters per second, you'll notice I put my second on the bottom, the meters on top, because that's really what that means. Meters per second means meters on top, seconds on the bottom. And when you use this, mile is approximately 1 kilometer is 0.621 miles. Since I need to convert that, I need to go 1,000 meters is equal to 0.621 miles, because a kilometer is 1,000 meters. And then now I'm in miles, and then to get to my seconds, there's basically 3,600 seconds in 1 hour. Plugging that in, I get 3,353,400,000 miles per hour. And again, since there's only 3 sig figs in the beginning, I need to change this to 3 sig figs as well. And I get 3.35 times 10 to the 9 miles per hour. So that's pretty fast. Warp speed is very fast. So hopefully that helps you get an idea how to convert. There's 3 different types of conversions I showed you. The first one was just a basic one. The second one was an area one. And the third one actually had 2 units in it. And I showed you how you had to put the seconds on the top to cancel out the seconds to go to hours on the bottom. So hopefully that helps you. If you have any more questions, come see me during tutoring.